If I told you this single image took days, machines, and entire teams to make, would you see the universe differently? Stay with me. In minutes, you'll know exactly how space telescopes turn invisible photons into jaw-dropping pictures. Imagine a single photograph that took days, machines, and entire teams to create. You see this one picture and it shows a distant galaxy, a vibrant star nursery, or a mysterious planet. You might think it was captured in just a single moment, a quick snapshot of the cosmos. But it was not. That image is the final product of immense planning, brilliant engineering, and even a touch of careful art. It represents a long and complex journey. Stay with me for this exploration. I am going to show you exactly how a magnificent space telescope creates that one perfect image, floating silently in the void that inspires us all with wonder. Space telescopes are our eyes in the cosmos, allowing us to see incredibly far-away things with stunning clarity. They orbit high above our planet, far from the blurring effects of Earth's atmosphere. This unique position allows them to see very faint light from the most distant corners of the universe. They can also detect infrared ultraviolet that our atmosphere blocks. Hubble Space Telescope, James Webb Space Telescope. They have given us some of the most iconic pictures of space ever seen. But making those breathtaking pictures takes many complicated steps. Many dedicated people work for a very long time to produce a single image. Sophisticated machines and powerful software do much of the heavy lifting, guided by human expertise at every stage. This essay will explain the entire fascinating process from start to finish. Our journey will begin with the initial spark of a scientific idea. It will follow the light as it travels across millions of light years. We will see how raw data is collected and cleaned. Every single breathtaking space image begins not with a camera shutter, but with a simple, powerful question. A scientist, or more often a team of scientists, asks something fundamental about the universe. What do we want to see? What mystery do we want to solve? They carefully pick a target for their investigation. It could be a newly discovered exoplanet orbiting a distant star. It might be a massive, swirling galaxy billions of light years away. Or it could be a dusty, dark nebula where new stars are being born. The team studies everything that is already known about this object. Then they formulate new questions that can only be answered with new observations. Once the scientific goal is clear, the team writes a detailed observation plan, called a proposal. This document is like a complex recipe for the telescope. It explains exactly what they want to observe and why it is scientifically important. The plan specifies exactly when the telescope should look at the target, accounting for its position in the sky. It details how long the telescope needs to stare at the object to collect enough light. Most importantly, it outlines which of the telescope's specialized instruments and filters should be used. Space telescopes like Hubble and Webb are incredibly valuable and have a limited amount of time available for observations. Many research teams from all around the world are constantly asking for a chance to use them. To decide who gets time, a special review board is assembled. This board consists of expert astronomers who carefully check each and every request. They rigorously evaluate the scientific merit of each proposal, selecting only the best and most promising science projects. This competitive process can take many months, and only a fraction of proposals are accepted. This ensures that every minute of telescope time is used for the most impactful research possible. Good planning is absolutely essential for the success of a mission and the safety of the telescope. The schedule must be perfect to make sure the telescope can point at the target without its sensitive instruments being exposed to the blinding light of the sun, earth, or moon. A well-crafted plan saves precious time and resources. It also guarantees that the telescope can maneuver safely from one target to the next. The entire observation campaign is choreographed with immense precision, often months in advance, or even years in advance, all stemming from that initial scientific question that someone dared to ask about the cosmos. Once a plan is approved and scheduled, the telescope must perform a delicate dance in the silent vacuum of space. It needs to point at its distant target with almost unimaginable steadiness. To achieve this, space telescopes are equipped with a suite of sophisticated guidance systems. Gyroscopes, like super-precise spinning tops, sense any rotation. Reaction wheels, spinning flywheels that turn the telescope without rocket fuel. Star trackers, small cameras that look for known star patterns to find orientation. These parts work together to keep the massive telescope perfectly still, locked onto its celestial target. Even the tiniest motion, smaller than the width of a human hair seen from a mile away, can blur the final image and ruin the observation. To maintain this incredible stability, the telescope often locks onto a nearby guide star, a bright, well-known star used as a fixed reference point. By keeping the guide star perfectly centered in its special sensor, the telescope corrects tiny drifts and vibrations. With the telescope perfectly aimed and held steady, the main event can begin: collecting photons. Photons are tiny particles of light that have traveled across the vastness of space, sometimes for millions of years or even billions of years from the target object. This faint light enters the telescope, bounces off the large primary mirror, then off a secondary mirror, and is finally focused onto the detectors. These detectors are advanced digital sensors, similar in principle to the one in your phone camera, but far more sensitive. They turn each individual photon into a tiny electronic signal, a number. These raw signals are not a picture yet. They are a long stream of data, a massive collection of numbers. For extremely faint objects, the telescope may need many individual images over a long period. It might stare at the same patch of sky for hours or even days. The data from each exposure is saved. Later, separate observations are combined or stacked to build a stronger signal and reveal hidden details. A space telescope is not just a single camera. It is a flying observatory packed with different scientific instruments. Each instrument is designed for a specific purpose and can see the universe in a different way. The telescopes have powerful cameras, spectrographs that split light to analyze chemical makeup, coronagraphs that can block a star to see faint planets. In addition, telescopes have a wheel of different filters. Think of them like colored sunglasses for the telescope. Some let through broad blue, green, red light. Others isolate a very narrow slice of the spectrum. Narrowband filters highlight specific elements like hydrogen or oxygen. JWST is an infrared specialist. IR passes through dust to reveal newborn stars, galactic centers, and the most ancient galaxies. The raw data sensitivity differences, remove cosmic rays, and correct geometric distortion. Even after calibration, the data from the telescope is still not a pretty picture. It exists as files containing millions of numbers. Each number is the brightness of one pixel through one filter. At this stage, it's grayscale per filter. To create the final color image, these grayscale images are combined and assigned colors. Specialists use advanced software to begin the transformation. Adobe Photoshop, specialized astronomical programs. They assign a color channel, red, green, blue. For visible light, blue, blue, green, green, red, red, a natural color image. Many JWST images are infrared. Teams use representative or false color. They map long wavelengths to red, mid to green, short to blue, making invisible features visible. Then layers are combined, contrast and brightness adjusted to reveal faint detail without washing out highlights. A final cleaning pass removes remaining artifacts while preserving real structure. The goal, scientifically accurate and true to the data. You might look at a vibrant JWST image and wonder, are those the real colors? Color is a powerful tool for communication. Each color can represent temperature, chemical composition, or motion, a visual language telling the object's story. Blue often marks hot young stars. Reddish glow reveals hydrogen gas. Dark lanes show dust blocking starlight. If you are enjoying this deep dive, please take a moment to subscribe, like, and comment. A magnificent space telescope may be a marvel of technology, but it is the dedicated work of many people on the ground that makes every image possible. This is a story of immense human collaboration. Engineers design, build, and test. They craft flawless optics and sensitive detectors, engineer sun shields and guidance to keep it steady, and triple-check every part to survive space. Astronomers write detailed proposals, schedulers choreograph observations, operators pilot the telescope, data teams process and calibrate, and image specialists, working with scientists, translate the data into the visuals shared with the world. As we have seen, a single, stunning space image is the triumphant end of a long and intricate chain of events. It starts with the spark of a human question, months of meticulous planning, competition for telescope time, and precise pointing, patiently collecting faint photons that have traveled for eons, then crucial calibration to clean the data, followed by artistic processing that turns numbers into a visual story, a synthesis of science and beauty. Its colors encode science, its brightness encodes distance and structure, and its beauty connects us emotionally to the cosmos. Each photograph is a small, precious window into the grand expanse, and a mirror of human ingenuity. If you enjoyed this journey from a faint signal to a final, spectacular image, please show your support by subscribing, liking, and leaving a comment. Tell us which telescope image is your all-time favorite and why. Your engagement helps us share more stories of science and discovery with the world.